Good morning, everybody, and welcome to the homework helper for section 1.5. Let's go ahead and get started here. The first thing we're going to be working with are the properties of exponents. A lot of these property rules are already in the front cover here, but I do want to go over how some of these may behave slightly differently. So when we're looking at number 1 here, we see that we have the same radical. So when we have the same radical, anything underneath that radical will be multiplied together. So we'll get something like this. That can then simplify further because that would be the 7th root of x to the 5th. And then that's about as simplified as we can get it. We could write it as a fractional exponent if we want. Let's see what it wants us to do. Use simplify. Write your answers in exponential form. Yeah, so it wants us to write it as an exponent, not as a radical. So since this is the root, that's the denominator of our radical. So this would be x to the 5/7, and that would be our answer. Now when we're looking at a problem like number 2, where everything underneath is the same, but our radicals are different, well, let's start by converting our radicals into fractional exponents. So that this becomes x to the 1/3 times x to the 1/4 times x to the 1/6. And so what we remember before is that whenever we have the same base and we're multiplying together, our exponents are going to add together. So this is really, I'll do it up here, 1/3 plus 1/4 plus 1/6, and that's x to that power. And so now it's just adding fraction rules. So this will become 2/6. That gives us 3/6 plus a 4th. And then what can I do? I can turn this into 12, right? This becomes 12, this becomes 6, this becomes 12, this becomes 3, that becomes, what does that become? 9/12? 9/12? Did I do that right? 3, 3, 2, 2? Yeah, 9/12. And then 9/12 can reduce down to 3/4. So ultimately this becomes x to the 3/4. So on and so forth. So just be mindful of that as we go through all of these. Additionally, when we get to some of the more complicated ones down here, like I'm looking at number 5, we want to think about these as different bases. We see we have 2, 16, 8. We'll want to be able to put those in the same base because eventually we're going to have to multiply them together. So this would be the 4th root. I want to get it down to a 2 base, so that's 2 cubed times the 3rd root. I want to get this down to a 2 base, so that's 2 to the 4th times 6 root of 2. I can now rewrite it in fractional form. 2 to the 3/4 times 2 to the 4/3 times 2 to the 1/6. And then it's just adding fractions together at this point. All right, that is that. There's a lot of tricky little rules, but just take it slow. My recommendation is the first thing that you should do is convert it to fractional exponents. Try to get like bases and go from there because that'll be the easiest path. Next, this is just asking us to invert functions. And as before, all we're doing is we're taking our x and our y and we're swapping them. So if this is x and this is f of x and this is x and this is the inverse of f of x, all I'm doing is I'm swapping. My x becomes my inverse, my output becomes my input. My x becomes my inverse, my output becomes my input, etc., all the way down. All I'm doing is I'm taking them and I'm swapping them back and forth. Okay, let's look at the other ones though. Okay, when we're talking about a graph, when we're talking about taking the inverse of a graph, I do that fun little dance with our inverses, but what I want you to really see from that dance is that along the line x equals, or I should do this the other way, y equals x, okay? Just that line that goes, is that the right way? Yeah, it goes like that. Everything is just mirrored around that line. So when I'm thinking about the inverse here, you know, this point's going to be the same, this point's going to be the same, but instead of it going like this, it's going to go the other way. It's going to do something like this, except maybe more extreme. My line was a little sloppy. Yeah, something like that. Okay, because it's mirrored along that x equals y line. And that kind of makes sense because our x becomes our y and our y becomes our x, so it's going to reflect itself across that line. So just be mindful of that as we look at those graphing problems. For the equations, how you can do it however you want, but the way that I learned how to do it, and the way that makes the most sense to me, is just switching my f of x and my x's so that this becomes x equals -2 the inverse of f of x. And then from there, all I try to do is get my f of x by itself. So I'd subtract 4, divide by -2, and so here would be, what would that be? If I subtracted 4 and then divided by a -2, it would look something like that. Okay, so go through those step by step, figure out where you're at with those. And then there's one more section. Yep, last thing. All right, more composite functions, f of g of f and g of f or x, sometimes called FOG or GOF. But either way, all that we're doing is we're taking one function and we're putting it into the other function. So I'm thinking of f of g of x, here is 3, and then instead of x, it's g of x plus 7, but I know that g of x is all this, so this is 3, -4x minus 11 plus 7. 3 distributes, I get -12x minus 33 plus 7, or -12x minus, what is that, 26? I think that's right. And that's my f of g of x. Okay? So, and then you'll do that. You'll do it in reverse, find them both. Go through step by step and see how it all works. Be mindful. I mean, you're not really doing anything more complicated than multiplying and dividing on any of these, but being able to do it over and over again with precision is the key. So make sure you're paying attention to those small details. And that'll do it. Good luck, everyone.